Hello everyone, my name is Federico Crisci, and in this project I built a machine learning model to predict the electrical energy output of a combined cycle power plant using Microsoft Excel. Here you see the CSV that the project gave me. The goal of the project is to predict the net hourly electrical energy output, PE, of a power plant based on environmental conditions. The datasets include 9,568 hourly observations, each containing average values for temperature, T, uh, exhaust vacuum, B, ambient pressure, AP, and relative humidity, RH. Our task is to build a model that uses these variables to predict the power output, which ranges from around 420 to 495 megawatts. So, regarding our modeling approach, since we are predicting a continuous numeric value, this is a regression problem. I decided to use linear regression, and as you can see, I built my model using Microsoft Excel. I use the analysis tool pack, as you can see here. I enabled the add-in on Excel, and then I choose the regression to make this project. I use all feature for using all four feature as independent variables and PE as the target. And then, as you can see here, I created these three sheets for the first model using all four features. And then the last three sheets is my second model using just the temperature and the relative humidity to compare performances. As for the as for the models, I split the data sets of 8,000 rows, the training set of 8,000 rows, as you can see here. So there are 8,000 rows for the training set, and for the test set, the remaining 1,568 rows, as you can see here. So if I scroll down, here is my test datasets, and I trained the two models. So the same I did for the temperature and relative humidity model. After training both models, I used the test set to calculate predictions using the regression coefficients. I then compared the models using evaluation metrics. So the MAE, the mean absolute error, and the RMSE, the root mean squared error. For the final model, using all fold features, I obtained MAE, mean absolute error. So as you can see here. So after I've done the regression analysis with the tool pack, I found I first found my predicted PE, and then the absolute error and the squared error for all my rows. And then I calculate the MAE and the RMSE using these values. So respectively the absolute error and the squared error. And I obtain 14.18 for the MAE and 15.21 for the RMSE. The MAE means that on average the model's prediction different from the real energy output by around 14 megawatts. The RMSE is slightly higher, which is expected because it penalizes larger errors more strongly. Considering that the power output varies between 420 and 495 megawatts, these errors are reasonably small and suggest that the model has good predicted accuracy. The R squared value, and then we can see that for the second model, um, the output are different. So in this case, MAE and RMSE are even smaller than the previous one, 14 and 15. Even um, Also here, but what we have to see here is that even in this case, the RMSE is slightly higher than the MIE for the same reason that I said before. It's expected because it penalizes larger errors more strongly. Regarding the model interpretation, the R squared value from the regression output was um, um, like the R squared value show how well the model explains the variance in the data. And Based on both R squared and the error matrix, I chose the model with all four features as the final one, since it performed better than the simplified version. In conclusion, I successfully built and evaluated a regression model to predict power plant output using Excel. This project helped me understand the full modeling process from identifying the problem, preparing the data, training and comparing models to evaluating their performance. Thank you for watching.